yesterday we had a permutation that the order mattered. So like if we ran a race or we had a baseball lineup, the order mattered. Okay? Whereas if we have a basketball lineup, does the order matter on a basketball floor in which I put people out there? No. Okay? Whereas like with a baseball team or even like a soccer field, does it matter?
Yeah.
Not really.
Yeah.
You can go anywhere.
Yeah.
Huh?
No, it kind of matters.
Not really.
Like some people can't play defense.
Why not?
Because they don't know how.
Well, but they can still be there. So they did. So like if you're a forward, you can only go. You can't go past midfield, or can you go everywhere?
Oh, I thought you were talking about position.
Yeah.
Well, I'm saying a position really doesn't matter though.
Okay.
Like you're out on the field, because the goalie can still go anywhere, right? The goalie can still go take a corner kick. They can still go take a PK. They can't touch it with their hands outside the box, but they can go anywhere, right?
That was confusing. I didn't get that question.
Okay. Whereas like a baseball lineup, somebody has to hit in a certain spot. Okay? Football players, they can be anywhere on the field. Okay? Now, certain numbers obviously apply and things like that, but in terms of a basketball floor, I could have the little bitty point guard that's 5'2" guard the center that's 7'3", right? Essentially, that could happen. Do I want it to happen? No, but it could. Okay? Same way I could have two forwards or a goalie and a forward playing against each other trying to get the ball from. Right? So with a combination, the order doesn't matter. Does it matter whenever you order a cheeseburger from Five Guys if they put ketchup on it before the mustard? Is the ketchup and mustard still on the sandwich? Yes? So does it matter as far as the order in which they put it on there? McDonald's is harder than it needs to be. With a combination, order doesn't matter. It says if I have 3 items can be chosen, or I have 4 items and I need to pick 3 of them. It doesn't say that I have to order anything. I just have to pick 3. Okay? You go to the store, there are 4 things you want. Your mom says you can have 3 of them. Does it matter the order in which I pick anything? No. Okay? I'm still getting 3 of the 4. But the order doesn't matter. It's not like I have to do one before the other. So how many different ways can I select 3 things out of 4 items? How many different ways can I do it though? There's 4 things. I have to pick 3. So if I pick item A, item B, and item C, that's 1. What if I pick item A, item B, and item D? That's 2. What's another way of doing it? AC, well, AC and B is right here in the first one. AC and D. Order does not matter. That's what I'm trying to tell you, but you're not getting that part. Whenever it says right up here, with regard to order, it does not matter. I've said that I don't know how many times, so yes, I am getting frustrated because I think I've said it about a half a dozen times, that order does not matter. What's then the 4th one? B, C, and D, right? Where A's not... So there are 4 different ways that I can pick this. It doesn't matter which one I choose first. It doesn't matter if I choose item D and then I go back to item B and then I'm going with item C. Okay? I still get those 3 items, but it's not like a race where they have to finish first, second, or third. Okay? It's just like I'm buying it or I'm putting it somewhere, but order does not matter. So whenever we actually write the rule as far as a combination, similar to what we did yesterday, you're going to have N, but now it's going to be a C. Yesterday, it looked very similar to what we did here, but it was a P, it was a capital P instead of a capital C. P, obviously, or hopefully it's obvious that it means permutation. C is going to be a combination. So whenever we do this, we're going to use the formula of N factorial divided by whatever R factorial is times N minus R factorial. It's similar to the permutation, but we have to divide. Okay? The permutation part from yesterday was right here. We've got one added step, and we need to divide by whatever our R value factorial is. So same example, without having to actually write everything out, because that's going to take you forever, I would go 4C3. So whenever I do that, I'm going to have 4 factorial on top. I'm going to have 3 factorial times 4 minus 3 factorial. So then whenever I solve this, this is kind of an extra step that you don't necessarily need. But I have 3 factorial times 1 factorial. So on top I have 4 times 3 times 2 times 1 over 3 times 2 times 1 times 1 again. 3's cancel, 2's cancel, 1's cancel, and it's the 4 that we already found before. The formula, or the rule, whatever you want to call it, will keep you from having to actually physically write everything out. Okay? If you know how many total objects do I have, and then how many do I have to pick, then you go from there. So in this case, on the second one, it says how many ways can the starters, 5 people on a basketball team, okay, 10 people on the team, 5 people can go out there at a time. Okay? It doesn't matter in terms of who's playing what position. They're on the floor. They are playing the game. Okay? Because they don't stay on one person the entire time. They're all the way around the floor. The order doesn't matter. So then if I have 10 people, 5 people have to be on the floor, because you're not going to know the difference. The whole thing with a combination is you don't know the difference. Once they get out there, it says what position they're playing, but it doesn't tell you, like, once they get out there, you don't know what position they're playing. Does that make sense? It's not like baseball, okay? Or softball, or whatever you want to think about it. It's not like a track meet where it's just those people are there. So then I'm going to have 10 factorial on top, 5 factorial times 10 minus 5 factorial. Now, again, this middle step here, you can either choose to write it or not. That's completely up to you. But all I'm doing is just subtracting the 10 from the 5. So then, whenever I do this, I'm going to have 10, 9, 8, 7, 6, 4, 3. And then on the bottom side, I'm going to have 5, 4, 3, 2, 1, and I'm going to have it twice. Because I have 5 factorial on the bottom 2 times. hopefully as you get further into this, you won't write as much as you have to. Okay? So really it's just from here, if you don't have a calculator to do factorials, then you're going to need to write it out this way. What I would suggest is whenever you do that, like 10 is the same thing as 5 times 2. 4 and 8, the 8 becomes a 2. Same way, 3 and 6, the 6 becomes a 2. I'm really only looking at, whenever I'm multiplying this, as 9 times 2 times 7 times 2. Because everything on the bottom, okay, is going to cancel. It's going to work out. Okay, you're not going to have any decimals. Everything on the bottom, if you physically write all of this out, everything on the bottom will cancel. And you will only be left with the top. Okay, you can't have, okay, I can't put a half a blob of ketchup on a sandwich. The ketchup's either on the sandwich or it's not on the sandwich. Okay, if I'm trying to figure out different combinations of things. So then whenever I multiply those, I'm going to get 252. There are 252 ways that a basketball coach, where yesterday we talked about like a softball team or a baseball team, how they had to do their lineup. Basketball is not as complex because the order doesn't matter like it does with the baseball team or the softball team. Now, at the bottom it says, when finding the number of ways of an event A and an event B can occur. Okay? So if you have the word and with any two events, okay, if you have the word and, then what you're going to need to do with those two events, you're going to need to multiply. Whereas if you have two events and it's an or statement, so it says this or this can happen, then what you need to do is you need to add your two values that you get together, or your multiple events that you get together. Okay, a lot of this you do on a daily basis, or if you go out to eat or whatever, you just don't know it. You don't know how many options that you have realistically. Okay? So whenever we have like a standard deck of cards, okay, 52 cards in a deck, does it matter? There's 4 suits, different cards, okay, and the order of the cards which is dealt is not important. It doesn't matter what 5 cards I give you and the order that I give them to you, you still have the same hand in terms of a card game. Okay? In this case, I have a pair of 6s. Okay? It doesn't matter if I dealt the 9 last, I still have a pair of 6s. Does that make sense? Okay? I still have, it doesn't matter if the 7, it doesn't matter if the 2 6s get dealt together. I still have a pair of 6s in my hand. Okay, as far as what value the hand has. So whenever I do this, if I have, how many different 5-card hands can I possibly have? Okay, 52 cards, 4 suits, that's really not important right now. Okay, but 52 cards, how many different 5-card hands can I have? So how am I going to set this up in terms of a combination? If I have the C right here, what's going to go on the left side? What's going to go on the right side? How many total cards do I have? 52. Does it matter so much right now with the suits? Does that 4 mean anything to me? No. Okay, it's irrelevant. What number does matter though? The 5. Now, hopefully as you get to, the more you get to doing this, okay, you can understand that on top, whenever I have 52C of 5, okay, combination of 52 and 5, then that just means that the top side is going to have 52, 51. I don't want to write all from 52 all the way down to 1. Okay? You don't want that to happen. But what I do want to happen is just write the first 5 terms. 49 and 48. I don't need anything else there. Okay? Because whenever I actually divide everything here, if I would have 52 minus 5, what's 52 minus 5? 47. So it's going to count from 47 all the way down to 1, right? I don't want to write out 52 different numbers, and I sure as heck don't want to write out another 47, when all I'm going to do is what? Just cancel everything out. That's pointless. Okay? Work smart, not hard. The one thing I do need to add, though, on the bottom side is whatever 5 factorial is. So if I have 5 factorial, then I'm going to have 5, 4, 3, 2, and 1. That's going to be a lot easier to deal with than it is writing 52 all the way down to 1, and then writing 47 all the way down to 1, and then 5 down to 1 again. Okay? All I did here, I had 52 factorial, and then I had 5 factorial, and then 52 minus 5. Whoop. That was the 47 that I got rid of. That's why I could get rid of 47 all the way down to 1. So then really it just becomes, the 5 goes away with the 50. That becomes now a 10. 4, 3, there's 12, there's 24. 48 divided by 24 is 2. So I'm going to have 52 times 51 times 10 times 49 times 2. Again, this is if you don't have the capability of using factorial, this is how you're going to have to do it, as far as typing everything in or multiplying everything together. So then out of 52 cards, if I want to build a 5-card hand, there are 2,598,960. That's how many different hands that I can have. Okay? Now, think about the lottery. Think about why people don't win the lottery all the time. Okay? There's more than 52 balls in that little thing that spins around, right? Okay? And you've got to pick 6 of them. Okay? The order in which they come out doesn't matter. Okay? Now on one like 5, though, it says, in how many of the 5-card hands from example 4 are all 5 cards the same suit? So again, we have a stipulation. There's 2 things that are happening here. First off, how many different suits are there? How many? 4? So there are same suit, so I'm going to have 4 C1 times, okay, because it's the same suit and I still need 5 cards. How many cards are in one suit? We talked about it yesterday. 13. So first off, I've got to figure out which suit am I going to have. And then, so if I have all clubs, here, like we talked, it doesn't matter the order in which I have everything. It just matters that I have, in this case, 5 clubs. Okay? It's called a flush, for those of you that don't know. Okay? 13 cards, I need to be able to pick 5 of them. Again, it doesn't matter what 5 they are. It doesn't matter the order in which they get dealt to me. So first off, if I have 4 combination of 1, so if, out of 4, I'm going to have 4 factorial divided by 1 factorial times 3 factorial times 13 factorial, 5 factorial, and 8 factorial. Does everybody understand where the 4 and the 1 came from, and then the 13 and the 5? Anybody that doesn't? So 4 factorial divided by 3 factorial is just going to be 4. The other one's going to be 13, 12, 11, 10, and 9, because I have to have 5 of them. That takes care of the first 8. And then I'm going to have 5, 4, 3, 2, and 1. I can get rid of the 10 with the 5 and the 2. I can get rid of the 12 with the 4 and the 3. So in terms of how many values I have, I'm going to have 4 from the previous part times 13 times 11 times 9. Yes.
Where come from again? In the green?
From right here. From, because I had 4, 3, 2, and 1. And then I had 3, 2, and 1 on the bottom side here. Like it came from, does that make sense?
Yeah.
So then all those cancel. Okay? So whenever I multiply 4, everything there, 5,148 different hands. So there are 5,148 different ways that I can have a flush in terms of my cards that get dealt. Okay, and it's not even the best hand that's out there. It's pretty good, but it's not the best one. Next one. Okay, and I'm really going to go down to 7 more because we just did one just like 6. So here it says, suppose you can afford at most 3 ingredients in your omelet. So you go to this restaurant, omelets are $3. You can get, it's 50 cents per ingredient. You essentially, before tax, you have $4.50. Okay, you can get 3 ingredients. It doesn't matter if it's all meat, if it's all veggies, whatever. Now, the one thing with the omelet, why? But they still have cheese as an ingredient. Okay? In my opinion, if it's an omelet, it should have cheese included. Because if not, then it's just scrambled eggs. Okay? But whatever. So I have $4.50. Forget about the tax. Forget about the tip right now. Just $4.50. How many different ways can I make an omelet? Okay, and still afford this? Do I have here, and my next question then is then, how many, do I have to have 3 ingredients? Okay. I can just have one, I can just have 3, or have an omelet that's just eggs, right? Like I don't have to put anything in it. I can say, hey, I want a $3 omelet that has no cheese, no ingredients, and just eggs. That's still an option. It's not a very smart option, but it's still an option. Right? the waitress or waiter is going to look at me like this guy is a lunatic. Okay? He may anyway, but whatever. Okay? That's his own prerogative or her prerogative. So whenever I do this, I have basically 4 different ways that I can order any omelet. The first omelet I can order, how many different ingredients do I have? 10 ingredients. So the first ingredient I can order, I have 10 options. I can order nothing. I can just order eggs. What's another way to make my omelet? 10 ingredients. How many do I have to put in it? 1. What's another way that I can afford this omelet? 2 ingredients. And what's the last way that I can afford this omelet? 10 and 3. Why am I adding and not multiplying? Because it's or. Okay? I can have no ingredients, or I could have 1 ingredient, or I could have 2 ingredients, or I can have 3. I can't have 4. Okay, but these are all of the options. I'm adding because it's one or the other. So in terms of how many different types of omelets can I order? Okay, all it's going to do, it's going to be 10 factorial divided by 10 factorial, 0 factorial for the first one, plus 10 factorial divided by 9 factorial, 1 factorial, plus 10 factorial divided by 8 factorial, 2 factorial, plus 10 factorial divided by 7 factorial, 3 factorial. Have you noticed anything as far as what the bottom side 2 numbers are going to do every single time? Yeah. 10 plus 0 is 10, 9 plus 1 is 10, 8 plus 2 is 10, 7 plus 3 is 10. The 2 numbers on the bottom should always add up to whatever you have on top. Okay? If I would actually do this, I would have 1 plus 10 plus 45 plus 120. I have 176 different options that I could use to afford this omelet.